My name is Mohit, and this is my first YouTube video. Today I'm going to talk about variance and bias. What I've seen that we understand what is variance and bias, but there are some confusion around it. So I'm here to clear it out. So whenever people ask about it, okay, you know what it is in terms of machine learning or in general what it is. So let's see what is variance and bias. Okay, so variance, it's simple. It's a data spread out. It just tell you how the data is spread out. If you look into this example, okay, so you look into this some data points, right? And there is a mean of this data. Consider it. Let's say this is all weights. Let's say that these are weights. Okay. Variance lets us know that what is the dispersion of data around the sample's mean. This is very important. It tells us, okay, what is the mean of the data and how data is spread out around this mean. If they are spread out very far from this mean, then it's a high variance. If they are close to this mean, then it's a low variance. So if we look into this borderline and this borderline, so this is our data dispersion, and this is somehow tells us about this variance. So this is kind of a variance. This is not exactly, 10 kg minus 5 kg. It's not exactly 5, 10 minus 5 equal to 5. This is not 5, but somehow this tells us about this variance. We have a different formula to calculate variance. So please don't confuse that. Okay, it's just 10 minus 5. But variance is kind of tells us the degree of this dispersion of data, how this data is spread out. Okay, so if we look into this formula, so this is our formula for uh, variance. And we are summing up all the errors, which is xi are the data points and mu is the mean of the data. We are taking the square and we are taking the average. So this is the formula for variance, where sigma is standard deviation. So this is another concept. So sigma is nothing but a square root of variance, right? Generally, in machine learning, we use sigma because sigma is more appropriate to do some mathematical operations. That's what scientists found. And the reason is that if you see that it is giving the square of the differences, but if we do the square root, it will just give the data in the same unit. It would be in weight, not in weight square, but the sigma square will be calculated in the unit of kg if it is kg square, but sigma would be in kg, right? So that is the reason standard deviation is more preferred, though there is, as you can see, there is not much difference in both the terms. Now, what is variance with machine learning? It is a bit different when we talk about machine learning. So if we look into this, it indicates how much that model's prediction would change if it were trained on a different data set. So let's say we have a training data and we have a test data, right? So let's say model was trained on this training data. How would it predict on the test data? And that change will let us know about the variance. So we'll come to this first graph later. Let's see the second graph actually. Okay. So let's see this one. So this is our model, and which is capturing this training data very well. So these are training data points. It is capturing it very well. Now, if we try to predict the output on the test data, so you will find it, okay, so let's see, this is our test data points, right? We'll find that the model will predict the test data very well because this is a very good model. It's not overfitted, it is not underfitted model, right? So in this case, it would be having low variance. Why? Again, let's see what our definition says. Okay, it says that how the model's prediction change if it were trained on a different data set. Similarly, if we see this one, So this model is overfitted model. It is trying to capture each and every training data points, right? So if we try to see the observations on the test data, we'll find some errors because let's say these are our test data points, right? So we'll see that with the test data, the model prediction is not good. There are some differences. So this is the case of high variance. Right, now let's go back to our first. In this one, model is too naive and it is not capturing the training data set well, and it will not capture the test data also very well, right? So in this case, the prediction was is not good with the test data and model's prediction was not good with the train data as well, right? So this is the case of again low variance. Though it doesn't make sense, right? This model doesn't make sense. It is not capturing the data points very well. And we'll see later why this model is not good, but unfortunately, this is a case of low variance. Or or it could be high variance. Also, it depends, but looks like it would be low variance because it is not working good on the train data, it is not working good on the test data. Okay, now let's move further. Let's see what is bias. Bias in general, it's just an inclination for or against someone or something. Let's say, someone is biased against someone or someone is favoring, the other person. So it is all cases of bias. And we have a different kind of bias, data bias, algorithm bias, model bias. But in machine learning, we only talk about model bias. What is model bias? Bias is the error that occurs when a model is too simple to capture the two patterns in the data. It is the error that occurs when a model is too simple. So let's try to understand this. So if we look into again this diagram where model is too simple, it is not capturing the true patterns in the data. It is a case of high error. And that is the reason it's a high bias case, right? But if we look into the other one where the model is capturing the patterns of the data, so the error is low, and this is the case of low bias. Similarly, this is a third one where the model is overfitted and it is capturing the very minute patterns of the training data. It is also a case of low bias. But we have seen that this model is not good because it is having the high variance. We have seen this. And we are trying to find a model which is having low bias and low variance. But if we look into this model, this is having low bias and we have seen that this is having low variance also. This is a good model. We have low bias and low variance. In this one, obviously this is a high bias, so this model is no good. Unfortunately, this is having low variance. But again, it does not help, right? So that is the reason, considering it is a high bias scenario, this model is not good. So again, bias is the error that occurs when a model is too simple to capture the true pattern in the data. The error would be less if model is smart enough to capture the true pattern in the data. Okay, so we understand this thing. Now, just let's try to see this graph also, which is a graph between model complexity and error. If our model gets complexed or over complexed, we see that the bias is low, getting low if model is being more complexed. But the variance is getting increased if the model is getting more complex. So that is the reason we need to find something in between where the bias and variance is low. And that is the reason we see this total error graph as well, which gives us the point where the error is low at the minimum, and that is the point which we try to see, which we try to find the model which is the best model for us. Okay, so let's see the strategies to handle the biased variance trade-off. We can see, okay, if bias is getting low, variance is getting high. If variance is low, bias is high. So we need to find there are some ways to handle these cases. First one is regularization. Regularization techniques such as L1 and L2 regularization penalized overly complex model by adding a regularization term. So that's how we find the best model, and it penalizes the models which is very complex models. Similarly, we have cross-validation techniques like k-fold cross-validation, which again try to assess models' performance on different data set and figure out the best model out of it. We can do some feature engineering, select some feature, do some feature engineering to reduce the model complexity. And then we have ensemble methods such as bagging and boosting, which improve overall model performance. So that is all about variance and bias. Please let me know if you have further questions around it. I would happy to answer those things. I'm sure that this video would be helpful for you. Thank you.